Our first speaker is going to be Roger Wang from Rutgers University, and talking about the interdependence of coastal protection infrastructure systems from a hydrologist point of view. So, Roger.
Hello. Hi. Thank you very much for the opportunity to talk to in this great event. And today I would like to share our simulation work on the sea level rise research. So as we know that sea level rise is happening, which is fundamentally but quietly changing our lives. This is the graph people use satellites to examine the global mean sea level since 1993. And you can see that over the period, at average, sea level is rising by 3.4 millimeter per year. And also there's IPCC and other updated prediction of the sea level rise at the end of the century, which could be up to 8 feet at different locations. So it's a very dramatic change. But still, people are arguing why I should believe this this very wide projection. Why should we care about this millimeter increase? And people still argue that your scientists are making this up just for funding. But today I don't want to argue with these people. I want to show you more evidence. Here is a photo taken 3 years ago in Miami. Can you see anything unusual here? Anyone? Something different? Like, apparently a guy is paddling a kayak, but I would like to say, I would like to emphasize the weather. Have you seen that it's a sunny day? There was no storm, no precipitation, but still flooding is happening. That is called a sunny day flooding, or people call it nuisance flooding. NOAA has done a survey in 2016 and found different places over the United States. How many days of nuisance flooding happening? So you can see that for New York, it's on the left-hand side here, Battery, which is just across the river. You can see that it suffers like at least 7 days per year in 2015. And some places like New Jersey, it's more like 20 days flooding. And even DC, North Carolina, they're suffering more. So it's a big problem now. And it actually is influencing our infrastructure system. Like this is the example close to us, Broad Channel. So every month, people will see flood like that on the left-hand side. So you can see it's a quite problem for the local community and also infrastructure. In terms of infrastructure, if you see the places around this Broad Channel town, you can see that the JFK Airport, the wastewater treatment plants, and also power plants, they are all suffering from this. And close to related today, the drainage and water supply system will suffer from this consequence. So my lab is trying to look at how we can use the emerging big data and numerical model to support decision making. And today I would like to focus on a story that we use numerical model. So this story is in San Francisco. So every year when the sun, earth, and the moon align, you will see a phenomenon called king tide. That's the water level is the highest of the year. And this is in 2015 in San Francisco Bay. You can see that all these places are reporting floods, even though there was no major precipitation or storm event. And if you look at the different counties, they are actually facing different challenge. Like some counties, they have a longer coastline. Some have a small affluent community. And the different counties have different responsibility of their community. Generally speaking, there are two choices they can make. The first is called softening or accommodation. The second is called containment or hardening. So for softening, people generally create more wetlands and try to accommodate the flooding and also try to use the natural system to treat to mitigate the tidal and storm surge. Containment is simple: the building seawalls, building levees to protect the land so water cannot penetrate into the land. So we developed numerical models for San Francisco Bay, and you can see actually the bathymetry is very complicated. Some places are very deep, like in the middle, they have a very deep channel in the bay, and for the rest of the bay, the average depth is only 2 meters. So we developed this model, so you can see that tidal actually is happening when the blue area actually has higher amplitude of the tides. Because of the geology, the shape of the bay is interesting. The South Bay has the trumpet shape, so that's why the Silicon Valley has a very big tidal amplitude there. And also in the North San Pablo Bay, they have another resonance there, so that's why water level is also high there. And looking at the different places, if your county is at different location or your city is at some critical place, actually you are facing different risk of flooding. So what we are looking at first is the county level decision making. If we assume that if a county has the superpower to build a levee, for example, if the Marin County has the power, they can build a infinitely high and coherent seawall like the red line marked. What happened? What happened to this county and what happened to other countries? And we can do this for every country. So we have 9 scenarios, and we can compare with the existing levee. So for the model, for the current model, we are also including 250 levees. And this is one of the typical results. For example, if we are protecting Napa Valley, which is the red line shown in the left-hand side map, and you can see the black area is where water cannot reach because we are surrounding this county, so you cannot, the land will become dry, but water has to find a way to go other places. So you can see that the color for the existing sea level is only changing the north part of the bay, but for the future, like sea level rise 1.5 meters, that is a moderate projection at the end of the century. So you can see that the impact actually reached the south end of the bay. So that actually tells us something is behind this, especially when the future sea level rise is happening. So we can actually develop a network to show this interdependence. The arrows actually is showing which county is impacting which. If there's a major impact, we use a deeper color to show the influence. So you can see for existing sea level, it's just very few impacts, but with the future sea level rise, the North Bay and the South Bay start fully coupling impact. So which means they are fully there's a nonlinear impact to each other. So that actually tells us 2 things. One thing is when you develop your own levee, you should care about your neighbors, don't flood them, right? Another thing is you have to consider others' impact on you, whether your seawall is high enough. Can you protect yourself? If you don't care about others, others will not care about you. So that means the society has to build a common consensus on this. So collaboration actually can address the problem. We are also looking at how the transportation system is impacted by this, and we found that if some critical link, like the Berkeley Harborfront, if there's a very critical highway, if that is cut, you can even see the traffic jam can penetrate into the inland like 100 miles away. So you can see local impact can make a regional, local disruption can make a regional impact. So now this year I moved to Rutgers University. So we developed a model. The model is ready, which is good for New Jersey and New York. And now we are ready to use this model to make some predictions and also make some early warning systems. But from the perspective of modeling, actually, we are very troubled with this subsurface system, because usually when we simulate this, ask people what happens, what should we do with the drainage system, because we have no knowledge about this. They say, oh, usually we just block it because it's so simple. We ignore that because we think that the trash is too much and just block it. Or other ways, people say we artificially assume some coefficient that we remove water suddenly from this modeling, then just make some assumptions. So now I think this is a point that we have to improve that. I think especially today, I'm looking for collaborations. If anyone can collaborate with the better data of the drainage system, I'm very happy to collaborate. Thank you very much. That's all my talk.
Thank you very much. Do we have a question from the audience, maybe?
When you talk about the local drainage system, are you talking about the sewer outfalls or just the way the natural water bodies flush out?
The sewer system.
Sewer system.
Yeah, that actually can change a lot. Thank you.